This is part 284C3K24. This is a WOW video. It's a continuation of lots of videos in this section. Line 22 is really, really huge. It's massive. Like, just so many videos. It's unbelievable. It's probably over, like, I'd say 50 to 100 just in that one line. Okay, so it's line 22f1fa19c3k24, Neutron Flux Level Reactor Patent Wow Seti. So this has patents in it. Okay, so these are inventions that people have created that may not be used or might already be being used. Okay, so there's our Wow Seti alien radio signal. There's the answer to it. And if you don't understand what all this means, go to video number 1. It'll explain it. Yeah, we're in the, So 22nd of October 2012, when I was doing the research. Today is November the 19th, and I'm having trouble talking today and thinking. Just so you know, I do apologize. I have bad days with my brain injury. Okay, so neutron flux level Google. So I went to a calculator. I used this calculator to determine the relative neutron flux at a particular location. So you go to www.seutest.com. So quote from Wiki: startup neutron source is a neutron source used for stable and reliable initiation of nuclear chain reaction in nuclear reactors. When they are loaded with fresh nuclear fuel, whose neutron flux from spontaneous fission is insufficient for a reliable startup or after prolonged shutdown periods. Neutron sources ensure a constant minimal population of neutrons in the reactor core sufficient for a smooth startup. Without them, the reactor could suffer fast power excursions during startup from the state with too few self-generated neutrons, new core, or after extended shutdown. So here's the patent thing that I found. And the diagram's quicker, so let's put the camera this way so you can just see what it looks like. I'll go back this way. That'll make you dizzy, right? Here's another one here. Publication number. Westinghouse. Google.com patents EP04795331B1. Next came up the Journal of Geophysical Research, Volume 71, from 1966. That's an old one. There's the DOI number. This should have been bolded for you so you could see it just a little bit better. There, how's that? That's better. Okay, cosmic ray produced neutrons at ground level. Neutron produced production rate and flux distribution. Mikio Nashimita, Lloyd Stevens, and Wade Patterson, Wade Patterson, from California, University of California, Berkeley. Lawrence Radiation Laboratory. The absolute rates of cosmic ray neutron production and neutron flux distribution on the ground were determined at sea level and mountain altitude at geomagnetic latitude of 44 degrees north in 1964. Okay, so the thermal neutron flux was measured with a well-calibrated BF3 counter. A Maxwellian energy distribution with a shifted neutron temperature was assumed. While using two differently moderated BF3 counters, the fast neutron flux was determined in the energy range of 0.4 eV to 10 MeV. The neutron fluxes were also estimated from the measured production rate, and they are in good agreement with the measured fluxes. Possible occurrence of air-ground boundary effects on the neutron flux distribution was considered. Anisotropy of the thermal neutron flux on the ground was experimentally demonstrated, and the angular distribution was well filled by the first two terms of a spherical harmonics expansion. The air-ground boundary effects are discussed on the basis of experimental results. And that was received July 1965. And that's from www.agu.org. Okay? So thanks for watching that video, and we'll go on to our next one.